We are going to start using some new notation over the next couple of days, and I just wanted you to be comfortable with it. The first thing we're going to talk about, sort of as a review, is integers. Integers is the set of the whole numbers and their negatives. Okay, so this is the symbol for integers. It's a double-backed Z. Okay, I'm not sure why it's Z, but this is similar to our real numbers. Remember, we have the double-backed R. So integers is Z. Again, I'm not sure why, but it's just a double-backed Z, and that shows the set of integers, and the set of integers are these numbers here. Okay, so what we are going to see is this is a shorthand for lists. Okay, so we are going to see something like x is equal to 0 plus pi n, comma means where, n, this is an element of the integers. Okay, so we are looking for all the numbers 0 plus pi n, where n is an integer. So all we're going to do is we're going to substitute in our integer values. I always start with 0, right, for my n. So 0 plus pi times 0 would be 0. So 0 is one of my numbers. Then if I let n equal 1, pi times 1 is 1. 0 plus pi is pi. If I let n equals 2, this is going to be 2 pi. 0 plus 2 pi is 2 pi. Okay, and hopefully you would be able to see it's going to go on 3 pi, 4 pi, 5 pi, etc. Okay, but we can also let n be integers. We can let n's be negative values. So if n is negative 1, pi times negative 1 would be negative pi. 0 plus negative pi is negative pi. Okay, similarly, if we let n be negative 2, negative 2 pi plus 0 would be negative 2 pi. Okay, and hopefully you could see it would go on and on like that. Okay, so instead of having to write out this list every time, we can write these two things are equivalent. Okay, x equals 0 plus pi n, where n is an integer, is equivalent to this list of numbers. Okay, so similarly, this time we are going to have 0 plus pi fourths n. Again, n is an integer. So like I said, I always start with 0. Pi over 4 times 0 would be 0, plus 0 is 0. If n is 1, this will be pi over 4 times 1, which is pi over 4. 2 pi over 4 would be pi over 2. Okay, this is just arithmetic, and the list would go on like that. In the negative direction, pi over 4 times negative 1 would be negative pi over 4 plus 0, so we have negative pi over 4. And negative 2 times pi over 4 would give me negative pi over 2 plus 0 would be negative pi over 2. Okay, again, it would continue in this direction. Okay, a couple of things. A lot of times you're going to see it start at 0, but it doesn't have to. Okay, and you can find any multiple of n, okay, to create your list. But these two things are equivalent. We want to get more comfortable with that. So pause the video, please, and I would like you to try the next one on your own. Okay, hopefully your list looks like mine. Okay, negative 2 pi over 3, negative pi over 3, 0, pi over 3, 2 pi over 3. All right, more often than this, okay, you do want to go from your this is called set builder notation to a list, but more often is that we're going to have a list and we need to go to set builder notation. Okay, set builder notation, we can only use this if there's a constant, if interval. Constant means the same, right? If there's the same difference between all the numbers in our list. So hopefully here you can see the distance between negative 2 pi and negative pi is pi. The distance between negative pi and 0 is pi. 0 and pi is pi. Pi and 2 pi is pi. So I figure out real quickly that I am always adding pi, and it just depends which integer I'm multiplying by. And then you could pick any of these values as your start value. I generally will use 0 because it's the easiest. So 0 plus pi n, but we didn't define what n is yet. Okay, so it's really important that we're going to tell everyone that n is an integer. Okay, so I draw my z, and then I draw in a double back. Okay, our next one. Hopefully, sometimes it's hard to look in the negatives, so if you want to look in the positives first, okay, but hopefully you can see each step we are going up by pi over 2. Okay, so I'm going to have pi over 2. Oh, I'm sorry. Pi over 2n. Okay, that's the steps that I'm going, and I do have a 0 here to start. And I need to say that n is an element of my integers. Okay, our next one. 0 to pi over 8 is pi over 8. Sometimes it might help you to put all of these with the same denominator. This one's wrong, sorry. Okay, so hopefully you can see 0 to pi over 8, we're going up by pi over 8 to 2 pi over 8. Again, we're going up by pi over 8, 2 pi over 8 to 3 pi over 8. We're going up by pi over 8. We're multiplying that n times. We're starting at 0. And again, n is an element of the integers. Okay, so please pause the video now and try the next one on your own. Okay, I rewrote pi over 3 and pi over 2 in terms of sixths. Then it's pretty easy to me to see that we're going up by pi over 6, n times. My starting value is 0, so 0 plus pi over 6n, where n, I apologize about that, where n is an element of the integers. Caught my mistake. As always, please ask me if you have any questions about this. We'll be using it pretty frequently over the next few days.